All right, this is Mr. McCord's ICP class, Unit 4, Lab number 3, looking at flame tests. Now, what we do in the lab is going to be a little bit different than what we do physically, on paper or digitally, to kind of figure out what these different chemicals are made of, what their valence electrons are like, what they turn into as cations or anions to have their valence electrons bump around and release light. So I'm going to give you some examples of what you might have to answer on the lab, aside from just testing the chemicals and seeing what their flame color turns out to be. So first up is boron. Our isotope is boron 10. That means it's got a mass number of 10. It's got 10 protons plus neutrons. Now, you're going to need to look at your periodic table to figure all of this out. So make sure you grab your own or look at the one on Schoology. If you go find boron on the periodic table, it's got an atomic number of 5 up in the top left. That means it's got 5 protons. Okay? That's what makes this atom boron. Now, our mass number, this 10 in purple here, means we've got 10 protons plus neutrons. So if I have 10 protons plus neutrons minus my 5 protons, that equals 5 neutrons. So in this case, they match. Not always, but in this case, they do. My total electrons does match my number of protons. So if I have 5 positively charged protons, I've got to have 5 negatively charged electrons. My number of valence electrons comes from what column my element is in. Boron is in the 13th column, right, across the transition metals. So it should have, knock the 1 off of the 13, 3 valence electrons. So to figure out what kind of ion this becomes, we want to see, whether it's easy to reach 8 valence electrons and get a full set, or to just give up and lose all of them to drop down to 0, have 0 valence electrons. So 3 is closer to 0 than it is to 8, so our boron isotope is going to lose 3 valence electrons. I'm just going to put Ve for short. Finally, to figure out the charge of this ion, we should be losing 3 negatively charged electrons, so it's kind of opposite. Okay, so if we lose 3 electrons, our original neutral charge of 0 minus a negative 3, losing 3 negatively charged electrons, equals positive 3. So our net charge of our ion, our cation in this case, because it's positive, is positive 3. Okay, radium-226 is up next. All right, our number of protons in radium, again, is the top left. The atomic number of radium is, if you go find it on your periodic table, 88. All right, so radium has 88 protons. It has 226 protons plus neutrons. So if I take 226 protons plus neutrons and subtract out my 88 protons, that should be equal to the number of neutrons. Now I can't do that in my head, so I'm going to pull out a calculator. 226 minus 88. That gives me 138. Make that a little bit wider. Maybe I can't. Well, that's okay. It'll just be kind of bumped down there. Okay, so we've got 138 neutrons. Again, our total number of electrons matches the number of protons. So if we have 88 protons, we have 88 total electrons. If we go find the column that radium is in, it's in the second column. It's in the alkaline earth metals. So it has 2 valence electrons for being in column 2. Okay, it's way easier to lose 2 valence electrons to reach 0 than it is to gain 6 electrons to get to 8 valence electrons. So we are going to lose those 2 valence electrons, which means we're taking a neutrally charged atom, charge of 0, and losing 2 electrons, which leaves us with minus a negative. That is a positive 2 charge. You may also notice if I'm giving you the symbol for the ion, it has the charge up in the top right. That should match the charge that we get over here. So this +3 should be the charge of this ion. +2 should be the charge on this ion. We might have a shortcut here for the last one. Okay, so finally, cesium is in the first column of the periodic table. Its atomic number is 55, so it has 55 protons. 133 protons plus neutrons minus 55 protons should give us the number of neutrons. So again, calculator, 133 minus 55 gives us 78 neutrons. Our total number of electrons matches the protons, 55 total electrons. Again, it's in the first column, alkali metals. So 1 valence electron, it is way easier to lose 1 valence electron than it is to try and gain 7 to reach 8. So this ion of cesium is going to start neutral. It's going to lose 1 valence electron. Oops. Lose 1 negatively charged valence electron. 0 minus -1 is +1, which matches our positive charge over here. So what you'll be doing in the lab is going to be very similar to what you see here.